Hello guys, welcome back to my YouTube channel. Myself Nikhil. Today's subject is Oops Java and the topic we are going to is understanding static operations. Understanding static operations in Java. In Java, static operations are fundamental to creating efficient and reusable code. Understanding static variables, methods, and blocks is crucial for developers to effectively manage class behavior and data. Introduction to static operations. Class level operations. Static operations are associated with the class itself, not individual objects. Shared resources. Static members are shared among all instances of the class. Memory efficiency. Static members are loaded into memory-only space regardless of object instantiations. Code organization. Static operations facilitate the organization and reuse of common functionalities across objects. Static versus instance variable. Features. Scope. Static variable is class level. Instant variable is object level. In terms of memory allocation, static can be shared and instance is unique per your object. Access, it is directly through the class. In terms of instance, through object references. Static methods and their usage. Utility function. Static methods provide utility functions that operate on data or perform tasks without requiring object creation. Second, class level operations. They can be used for tasks like initializing constants or performing calculation. Third, factory methods. Static methods can act as factory method for creating class of specific type. Accessing static members through class name. Static members are accessed directly using class name through object reference. Static members can also be accessed through object references, although this practice is generally discouraged. Direct access. Static members are readily available without the need for an object instance. Static blocks and initialization. Static block execution. Static blocks execute once when the class is first loaded into memory. Initialization. Static blocks can be used to initialize static variables, perform setup tasks, or load resources. Constructor relationship. Static blocks execute an constructor of the class before it is called. Static imports and their benefits. Code readability. Static imports eliminate the need for repeated class name qualification when accessing static members, enhancing readability. Convenience. They simplify access to frequently used static members, reducing typing and improving code clarity. Maintainability. Static imports help avoid code duplication and promote consistency when referring to static members. Static classes and nested static classes. Nested static classes. Static classes are nested with other classes and have no access to instance variables of the enclosing class. Utility classes. Static classes are often used for creating utility functions or promoting related static methods and variables. Inner classes. Nested static classes are independent of enclosing and can be accessed directly using the class name. Advantages and disadvantages of static operations. Advantages: memory efficiency, code reusability, simplified access, global scope. Disadvantages: limited flexibility, state management challenges, testing difficulties, potential for side effects. Best practices for using static operations. Minimize use. Use static operations judicially, favoring instance members when possible. Constant. Define constant as static final variables, ensuring mutability and shared access. Initialization. Using static blocks for setup and initializing tasks when necessary. Thank you for watching. Please like, share and subscribe.